What is the difference between linear and rotary actuators? Have you ever wondered how machines move? Today, we will discuss the differences between linear and rotary actuators. These two types of actuators are essential in robotics and automation, and they serve different purposes. First, let's talk about linear actuators. These devices create motion in a straight line. They typically push or pull along a single axis. Imagine a robot moving back and forth to pick up objects. That is a perfect example of a linear actuator in action. On the other hand, rotary actuators produce rotational motion. They move objects around a fixed axis or pivot point. Think of a steering wheel turning in a car. That is how rotary actuators work. They allow for smooth and controlled rotation. Now, let's break down the differences in motion direction. Linear actuators move back and forth along a straight path. In contrast, rotary actuators rotate through an angle around a central shaft. This distinction is crucial when designing robotic systems. Next, we have the mechanism. Linear actuators often convert rotary motion from a motor into linear motion. They use components like ball screws, belts, or rack and pinion systems. Rotary actuators, however, provide angular motion directly without needing this conversion. When it comes to design and components, linear actuators usually consist of a motor connected to a gear and a threaded shaft. This setup creates linear displacement. Rotary actuators, on the other hand, contain cylindrical chambers with a central shaft that rotates within stationary barriers. Another important difference is the range of movement. Rotary actuators can often rotate continuously or through multiple revolutions. This allows for infinite or repeated angular motion. Linear actuators, however, have a limited travel distance, moving only within a defined linear range. Precision and control are also key factors. Linear actuators generally offer higher precision for positioning tasks along a straight line. This makes them suitable for applications that requiring exact displacement. Rotary actuators provide controlled rotation but may have less precision depending on the model. Space and mounting considerations are also worth noting. Linear actuators requiring space proportional to their stroke length as they extend and retract. Rotary actuators tend to be more compact and easier to mount, especially in tight spaces. Finally, let's look at applications. Linear actuators are common in robotics for tasks like lifting, pushing, or sliding components along a straight path. For example, they can move an arm segment or adjust a gripper. Rotary actuators are used where turning or pivoting is needed, like valve control or steering mechanisms. In robotics, choosing between linear and rotary actuators depends on the required motion type, precision, space constraints, and force or torque needs. Linear actuators excel in tasks demanding straight-line movement and precise control. Meanwhile, rotary actuators are preferred for continuous rotation or angular positioning. Understanding these differences helps in selecting the right actuator to optimize performance and efficiency in robotic systems.